Alright, this lesson is going to be on meter placement. It's actually the final lesson in circuits. There's one more thing I want to do, and it's called magnetic fields, but I'm going to wait until we get back to school to do that. If we don't come back, then I'll just go over it in a lesson video, but I do want to save it for when we come back. So this will be the final lesson in circuits. Now, the circuit itself. So in Regents questions, you're going to encounter problems like this. So, for example, number 6. Which circuit diagram below correctly shows the connection of ammeter A and voltmeter V to measure the current through and potential difference across resistor R? So what the hell does that mean, right? What the hell does that mean at all? So let's take a look at ammeter A. What does ammeter mean? So if we take a look at this, an ammeter is just like the name suggests. It is a meter to measure amperes, right? So it's ammeter, ammeter. So it measures amperes, measures electric current, right? It measures currents. So you're gonna use these are multimeters, and one of their functions is to measure current. And if we were in school and we did play with circuit boards, we'd use something we would call a current probe, which is this. So you connect this to a lab quest, and you would be able to measure current running through these circuits, right? Running through these circuits. Now, and that's what an ammeter is, right? An ammeter measures current. And so, what is a voltmeter? And we want to know what voltmeter means now. So voltmeter is just like the name suggests, it measures voltage. Right? It measures voltage, and these multimeters will measure voltage too. In university, you use these actually. So they measure various quantities. They can measure both current and voltage, not including those though, just those, not including just those, but plenty more. But in lab, we would use this to measure voltage, right? This would also connect to your lab class, and that would be your voltmeter. But for the purposes of Regents, uh, they used to use ammeters and voltmeters, so they put them separately, right? They put them separately. So how would we solve this, right? How would we solve this problem? Well, let's take a look at this circuit right here. How would we correctly measure the current running through a resistor? Right? So on this left-hand side, you see a circuit connected in series, and you see another circuit connected in parallel. Yeah, this, by the way, is a FET simulation. FET simulation. I'll put the link below, and well, not the link below. What am I talking about? I'll put the link in the assignment, the homework assignment on Google Classrooms. Oh, but yeah. So how would I correctly measure the current running through a resistor? Well, you see here that when you connect something in series, your current is the same. So as long as you connect that something in series, you are connecting the ammeter correctly. So you want to connect your ammeter in series, because you know that if you connect something in series, your current will be the same. So which is what's happening here. I'm connecting something in series, right? And you'll see that my current here is still 1.678, right? So that's my current. So as long as you connect something in series, you are measuring the current correctly. So it has to be connected in series. So let's take a look at this parallel circuit. Well, what if the problem said, what is the correct current running through a single light bulb? Well, for me to correctly measure the current running through a light bulb, I would have to connect this current probe, in series. Again, right now this current probe is connected in series, so the current running through this resistor is 1 amps. Same thing over here. I'm connecting this current probe in series, so I'm only measuring the current running through this light bulb. Not this one, just this one. Well, if the problem said, well, what is the total current running through What is the total current running through a uh, the entire circuit? Well, if you wanted to measure the total current running through the entire circuit, you would have to connect it in series either before, right? Either before it splits up, either before the current splits up or after the current combines back again, right? Because you want to connect in series, and you don't just want the current running through one resistor. You want the current running through the entire circuit, right? So that's how you would answer that problem. Well, now how would I measure voltage, right? How would I measure voltage? Well, if you take a look at this part right here, this formula on your reference table right here, parallel circuits if you connect something in parallel, the voltage drop, the potential difference across each resistor is the same. So as long as you connect something in parallel, the voltage will be equal. So if I connect this in parallel right here, that my voltmeter, this is my voltmeter, I connect it in parallel, 1.67, 1.67, 1.67, right? So let's move on to over here. My voltage is 1 meter, which is represented by this battery. This battery has a voltage of 1 meter. This also has a voltage of 1 meter. It also has a voltage of 1 meter. So since these two are connected in parallel, they have the same voltage. So let's increase. So no matter what, even though I increase my resistance here, my voltage is the same, right? My voltage is the same, and my voltage is still the same. So to correctly place a voltmeter, I must connect it in parallel. I must connect it in parallel. And to correctly place an ammeter, I must connect something in series. So let's actually move on to the practice problems right now. So in which circuit, number one, in which electric circuit would the voltmeter read 10 volts? So again, you want to connect a voltmeter in parallel, right? If it's in parallel, it will have the same voltage reading. It will have the same voltage reading. Now, so let's look at choice A. So again, you want your voltmeter in parallel. All right, you want your voltmeter in parallel. Let's look at choice A. And it's easier to think of these choices. It's easier to think of these choices without the voltmeter attached. All right, so I'm just going to ignore the V at the top for choice A. So this is choice A. This is 20 volts. Well, if you think about it, it says that in parallel circuits, your voltage is the same. So this is in parallel, these two are in parallel. That means my voltage here is 20 volts and my voltage here across this resistor is 20 volts, which means that if I connect a voltmeter here, this voltmeter will also read 20 volts. So choice A is clearly wrong. Well, choice A, it is in parallel. It's reading 20 volts. So that's clearly wrong. Choice B is kind of saying the same thing, just in different format. The voltage drop across each of these resistors. It's better to think of this without the voltmeter again. So this right now is in series. So if this is in 20 volts and in series circuits, your total voltage is equal to each individual voltage running across each resistor. So this is 10 volts and this is 10 volts. But even though each of those are 10 volts, your voltmeter is connected in parallel to the entire thing. It's connected in parallel to the entire thing. So the voltage running across this voltmeter is 20 volts, right? Because you know in parallel circuits, this is in parallel. It's parallel to the entire thing. So that leaves us with choice C and D. So again, you want your voltmeter in parallel. Okay, you want your voltmeter in parallel. Uh, so again, it's better to think of it without. Better think of it without the actual voltmeter attached. So this is 10 volts. So again, it's each of these are detached, but they're equal. So the total current, total voltage running through each resistor is 5 volts because it's connected in series. But if you suddenly connect something in parallel to only one resistor, you know that your voltage is the same because in parallel circuits, V1 is equal to V2. So this voltage right here, if it's in parallel, is equal to each other. So this voltage right here is 5 volts. So C can't be it, right? Because it's saying that the voltmeter is reading 5 volts. Let's look at choice D. And choice D is the correct answer, mainly because that's the only one left, right? There's no choice E. But if I were to explain it, you would just say, well, this is 10 volts, and this is in series. This is in series, so it's 5 volts each, because you know in series, your voltage is added. It says so on your reference table, right? Your voltage in series circuits is added. But if you connect something in parallel, and this is being connected to the entire thing, not just one anymore, to the entire thing, which means that the entire voltage is 10 volts. So this voltmeter is reading 10 volts. So the answer choice is D. Okay, answer choice is D. So number 2, diagram below represents 3 ohm resistor. So again, it's better to, let's just draw it without the actual meters. So this is 12 volts. This is 3 ohms. And the current, we're using this formula. 3 is equal to 12 over I. So 3I is equal to 12 4 amperes. So your current is 4 amps and your voltage is 12 volts. So again, if you want your ammeter to read 4 volts, you must connect your ammeter in series, right? That's something you always need to remember. And you must connect, and for your voltage to read something correctly, it must be in parallel. So X is in series. So if you want something to read something in series, you want X to be in series. You want your ammeter to be in series. So it's X is in series. So X is 4 amps. X is your ammeter. So X is your ammeter. And your voltmeter is connected in parallel. And it's going to be your Y. This is Y. So your voltmeter is Y. So the choice answer is D. Right? Answer is D. Number 3, where should you put an ammeter and a voltmeter to measure total current of the entire circuit? So again, you want total current. Number 3, total current. So you want your ammeter in series, and you want it at the end or beginning, right? So that's where you want it. And if you want to measure total voltage, you want it in parallel. You want your voltmeter in parallel, and you want it at the entire circuit, or rather your battery, at battery. Okay, so let's look at current. So let's look at option 1. 1 looks good. Yeah, one looks like the correct place for an ammeter, but let's figure out something out first. Let's go to 2. Uh, if we place our ammeter at 2, what that is saying is that you're only measuring the current running through one resistor. Placing your ammeter at 2 is the same thing as this. It's basically what this is right here. If you only place your ammeter at position 2, you're only measuring the current through one of these resistors through this light bulb. Not through anything else, not through the entire circuit, just this one here. So clearly it can't be position 2. Position 3 is parallel, so it can't be parallel, right? You want it in series. And position 4 is in parallel as well. So position 1 is at the beginning or end, and it is in series to the entire thing. So it's either choice A or choice D. So it must be at 1. Your voltmeter now. So it can't be 1, right? It must be parallel, so it's either choice 4 or choice 2. Or choice 3. What 3 is saying, sure, right? It's connected in parallel. But you're only measuring the voltage across this resistor, not the entire circuit. And the question wanted you to ask you, what is the correct place a voltmeter to correctly measure the voltage of this resistor? Sure, put it at 3. But the question wants the entire circuit. It wants the entire circuit. So the only choice is at the battery, right? 4 is parallel to your battery. 4 is directly parallel to your battery, so that's where you want to put it. So it's measuring the entire voltage. In which circuit represented below are meters probably connected to measure the current for resistor R1 and the potential difference across R2. So again, your current, your ammeter must be in series, and your voltmeter must be in parallel. And you want your current running through resistor 1, so you want current through R1. So you want something in series with R1, so you want your ammeter in series, right? And you want your voltage, which is your potential difference, potential across R2. So you want in parallel with R2. So your voltmeter should be parallel to R2. So figure out which situation would you have a series A with R1 and a R2 parallel with your voltmeter, okay? So which one would that be? Remember, you want A in series with R1 and you want V in parallel with R2. And so that would get your answer. So from here on out, I kind of don't want to give you the answer. I'll give you hints, which is what I'm doing. You should be able to figure out the answer based on the hint. It's not too hard. So that's enough of a hint. In which circuit diagram best represents voltmeter V connected correctly to measure the potential difference across resistor R2? So it's measuring voltmeter again, right? And if you want to correctly measure voltage, you must connect something in parallel. All right, connect something in parallel. And you want to connect it in parallel to R2. So which one would that be? You want to correctly measure voltage in parallel to R2. So you can't be series, right? So it can't be connected in series. And you only want it for R2. So not R1, only R2. Only R2 itself. There are two choices here that fit this, and you're gonna have to figure out which one you're gonna use, right? Is it one or the other? And I'll let you figure that out. Again, you only want R2, not both. Right? You don't want the voltage across both combined, not both combined, not both combined. Just R2 itself. Just R2 itself. All right, and that should be enough of a hint. 6. So again, ammeter in series and voltmeter in parallel. So this is where you want your ammeter and voltmeters. Okay. That should be enough of a hint. And this is for 6, right? So you want your ammeter connected in series and you want your voltmeter connected in parallel. Which circuit diagram best represents the correct way to measure a current in a resistor? So again, you want your ammeter in series. Okay? And so that's it. That should be good. You guys should be fine.